Hello everyone, in this video I'm talking about chemical nomenclature with main focus on ionic compound. Chemical nomenclature is the system of names used to distinguish compounds from each other. Certain rules are needed to devise this name. But before we go into these names, I would like to talk about the different types of compounds that we have. We have ionic compound and molecular compound. Ionic compound consists of metal plus and non-metals. When the metal and non-metal combine together, they form ionic compound. For this naming purpose, we are going to be dealing with binary compounds. Molecular compound consists of two non-metals. That is, we have non-metal combining with another non-metal. Naming ionic compounds. We already know that ionic compound consists of a metal plus non-metal. So we have two types of metals in ionic compound. We have the type 1 and type 2. Type 1 falls into the category in which they form only one type of ion. We can find these type 1 metals in group 1, group 2, aluminum, zinc, and silver. Type 2 metals form more than one type of ion. Where can we find this in the periodic table? The rest of them, it is the rest of all the metals beside what we have here. For the non-metals in this ionic compound, we replace the suffix after the base name with IDE. For example, fluorine, the base name for fluorine is this, and when we replace it, it becomes fluoride. The base name for nitrogen is this, and when we replace the suffix, it becomes nitride. Oxygen becomes oxide. Phosphorus becomes phosphide. Sulfur becomes sulfide, and so on. Now, how do we name the type 1 cation? We name the metal just the way the name is written on the periodic table, and we name the non-metal replacing the suffix with IDE as we said. For example, if you want to name KCl, so K, if you go to the periodic table, is written as potassium. Cl is chlorine and it becomes chloride. So the name for this compound KCl is potassium chloride. CaO, Ca in the periodic table is calcium. And the O here represents oxygen and it becomes oxide. So we have calcium oxide. For the type 2 metals or cations, for this type of metals, name of cation is followed by a Roman numeral in parentheses. That parenthesis indicates the charge of the metal in that particular compound. For example, Fe2 plus is written as ion 2. Remember, is in parentheses. Then E3 plus is written as ion 3. To name CrBr3, we determine the charge on the chromium, which is our type 2 metal. So how do we determine the charge? We use this relationship here. The total charge on the cation is equal to plus the total charge on the anion equals to 0. So we say Cr, we don't know the charge of Cr, plus we have 3 atoms of bromine. We don't know the plus 3 into the charge of bromine equals to 0. So we have Cr plus 3 into -1. Br is in group 7 and the charge is -1. So we have this to be equal to 0. Cr plus 3 into 1 equals to 0. When we solve this equation, we have Cr minus 3 equals to 0, then Cr equals to positive 3. So this positive 3 is written in Roman numerals and placed in parentheses. So we have chromium 3 bromide. Let's try this example again to name Fe2O3. Our Fe is type 2 metal. So it is Fe is iron. Because it is type 2, we need to place in parentheses. This is oxygen is oxide. So we need to figure out what Roman numeral should be in this parenthesis. Like we said, we go back into this. The total charge on the cation Fe, we have 2 atoms of Fe. We have 2 Fe plus. We have 3 atoms of oxygen. And oxygen is in group 6, so the charge on oxygen is -2. We put -2 here, equals 0. Then we have 2 Fe minus 6 equals 0. Your Fe is going to be plus 6 over 2, which gives us positive 3. So we place this in Roman numeral, which is I. So the name of our compound is iron 3 oxide. Ionic compound containing polyatomic ions. So we name them the same way, except we use the name of polyatomic ions wherever it occurs. For example, NaNO3. NO3 is a polyatomic ion, and it is called nitrate. We have the list of polyatomic ions. We have these to be carbonates, sulfate, and so on. All right, so we now name the cation, which is sodium, as we have in periodic table. Sodium nitrate. Hydrated ionic compound. Hydrates are ionic compounds containing a specific number of water molecules. For example, we have MgSO4.7H2O. It means that this molecule, this compound has 7 water molecules. It's an hydrate. So we name the compound just the same way. And we have magnesium sulfate heptahydrate because we have 7 molecules of water. So the water becomes hydrate. In this example, our CO is cobalt. Cobalt is a type 2 metal. So we're going to have it in parentheses, which is cobalt 2 chloride. We have 6 molecules of water. It becomes cobalt 2 chloride hexahydrate. In the same manner, we can write formula from the name. If we are given the name, we can always write formulas. So we write the symbol for both methyl and non-methyl with their charges. Then we do a crisscross and drop the charge. For ionic compound, we can reduce the formula if it is reducible. Remember, only for ionic compound that is reducible. For example, calcium chloride. Calcium is Ca and the charge on calcium is 2 positive. Chloride is Cl negative. So we do a crisscross this way. The 2 positive comes here, we drop the charge, and 1 comes into calcium. So we write CaCl2. For lead 2 oxide, we have lead to be positive 2 because we already been told that it is 2 from the name. And our oxide is O2 negative. So we do another crisscross and we drop the charge. It becomes Pb2O2. However, this is ionic compound and this is reducible. We can reduce it. It's going to be ratio 1:1 and it becomes PbO. We have iron 3 oxide. Our iron 3 is Fe3 positive. We're going to do a crisscross and it gives us Fe2O3. Note, this is not reducible, so it still remains Fe2O3. Thanks for watching.